When you have oil spilled, you want to remove it from the environment as quickly as possible. What we essentially are doing is providing a system that is environmentally safe, uses natural materials. This is a system that will have impact. I think this can change the game.
Across the globe, there have been 13 large-scale oil spills over the last 37 years. Two of the most recent, the Deepwater Horizon BP oil spill and the Exxon Valdez spill, have been classified as two of the world's largest man-made disasters, and even now, years later, continue to have detrimental effects on the wildlife and ecosystems that surround them. While the U.S. Coast Guard manages a variety of extensive prevention measures and governmental policies have helped to control the rate at which these spills occur, the technology being used for when they actually do happen is surprisingly underwhelming and ineffective.
The boom technique has been used for 2 or 3 decades with very minimal advancement, and that's where there's a lot of need.
Booms are just temporary floating barriers composed of plastic and fabric designed to prevent oil spills from washing up on beaches and marshes, and to concentrate the spill enough so it can be skimmed or vacuumed from the surface by large skimmers.
You saw it very well used only in Gulf of Mexico, but it didn't prevent oil spilling over. If it worked, marshlands would not have been contaminated. Marshland was contaminated even when we visited 4 or 5 years later.
It's been over 4 years since the BP oil spill dumped 210 million gallons of oil into the Gulf of Mexico. The spill affected a total area of about 78,000 square miles, a space that could fit the entire city of LA 167 times. Of that 210 million, only approximately 6 million gallons of oil were actually removed from the water. In spite of the help of countless experts, scientists, and engineers, the cleanup effort fell devastatingly short. The only newer technique that was used during the BP cleanup effort was this super toxic dispersant called Corexit. When Corexit was combined with oil, the mixture became 52 times as toxic as the oil itself.
Massive amounts were used without any kind of study, without really much science behind it. That was what was wrong.
So how is it that we're one of the most technologically advanced countries in the world and we haven't figured out a good way to clean up our messes? The booms being used are borderline useless, chemical dispersants can be more lethal to the environment than the oil itself, and skimmers really only gather surface oil, not the heavier oil that resides in deeper waters.
For generations, we will be drilling and collecting oil and transporting it. We are not anywhere near eliminating the toxic effect of a spill, and they are going to happen. And we still don't have enough technology to handle it. This is going to affect our children and grandchildren. Forget about us. We are toxified anyway.
I traveled to an unsuspecting place to speak to someone who also thought there had to be more effective ways in dealing with oil spills. We're here at Fermilab, which is the nation's premier particle physics laboratory, to see Arden Warner. Arden's been working here for the last 20 years as an accelerator physicist, trying to understand the smallest particles of matter. Outside of his work in complex physics, Arden had a pretty simple idea to help with oil recovery and cleanup. He could organically magnetize oil. Hey Arden, how are you?
Hey, welcome.
Thank you so much. How does your day job play into this project?
In general, my background in physics and the type of work I do does involve playing around with electromagnetism. This was just inspired by the spill in the Gulf and trying to figure out how to do something about it. And I came up with the idea of magnetizing the oil, and that naturally led me to say, well, let me put something in the oil. Because oil by itself is not magnetic, so we put some magnetite in the oil that renders it magnetic, and then we pull it. And my intuition would be that if these particles are small enough, light enough, and form some sort of a bond with the oil, then if I pull it, it should come with the oil in it, especially if it's on water. Some of them fell through because the shavings were a random size, but a few stuck with the oil, and then when I applied a little refrigerator magnet, it moved, and it pulled the oil with it because there was no drag. There was very little surface tension. It didn't just come out of the oil and come to me. It came to me with oil on it.
And now it seems like it'd be significantly easier to sop up the oil now that it's congealed to the edge of this barrier.
You can actually remove the particles and we can pull them out of the oil.
For people who might not understand, what is magnetite?
Magnetite is a naturally occurring mineral. It's iron oxide, and it occurs in nature. Magnetite in this form is one of the most magnetic of the minerals found in nature. If you go to any beach around the world and you pull your magnet through the sand, you'll pick up some magnetite.
So you're putting something in the ocean that is already naturally occurring.
It's already there. There's forces between the molecules, the Van der Waals force it's called, where it's really the sum of the attractive and repulsive forces. These play a role in holding the particles in the oil.
So it's super responsive.
Yeah, it works just as well with heavier oils. Actually, it works a little bit better because the more viscous oils clings on to this magnetite a little bit better, so it moves rather easily. I've tried over 100 different oils, and I even tried heavy crude, and it does work.
And that heavy crude is what we're used to seeing in like BP oil spill.
Well, you see all types of oil spills. Some of them are heavy crude, some of them are sweet crude, which is weaker hydrocarbons. But yeah, you see all types.
This is obviously a freshwater tank. How would the magnetite respond in a saltwater environment?
Salt water would just be more buoyant, so it would work the same. But we do have oil spills in oceans, and we also have them in fresh water, lakes, ponds. Ocean wave does not disperse the oil. The oil still stays together in plumes, especially the heavy oils. You'll see, wave action, and you see large amounts of oil just floating around in plumes. And that's why they use booms to circle it and pull it in. Wave action alone would not be enough, and wave action certainly would have no effect on a magnetic field. Tide will obviously add turbulence, so if it was a hurricane or something, of course, you'll always have an issue. But it does not disperse the oil significantly, where this method wouldn't work.
I know wildlife is constantly affected by oil spills. How do you deal with oil that is affecting wildlife?
So I tried it on bird feathers. You can remove oil from bird feathers and other surfaces using this process.
The idea to magnetize oil isn't exactly a new process, right? What about this is different?
What I'm doing is using a very natural material. I'm not using any absorbents. I'm not using any chemicals. I'm not using anything that saturates. Using magnetite, which is natural to the environment, is what was inspiring to me. Using something that has no known adverse effects, at least not as bad as dispersants, for example. And in principle, you could troll the bottom of the ocean and pick up the magnetite again with a magnet.
After this demonstration, Arden wanted to show me these principles scaled up.
So this is actually the first time that Arden has done this experiment on this large of a scale. It's going to give us a better sense for how we can apply this to real-life scenarios.
Yeah, it's really sucking it in there, see?
It really is. It's moving very quickly. You can see a huge chunk of oil and magnetite collecting on this pad that's fixed to the magnet.
That plume we had has now disappeared, and it's right on the magnet.
After going through the principles behind how magnetizing oil with iron oxide actually makes for an effective, non-toxic cleanup method, Arden explained how these principles would be applied to a device he recently patented.
So Arden, how do you envision these techniques being applied to an actual technology?
Right, so you saw how the oil moves on water when we have added magnetite to it and then applied a magnetic field. What we've patented is a concept that will automate this by shaping the magnetic field so that we can guide the oil to a location where we can collect it, separate it, and reuse the particles.
Arden proceeded to explain this to me. A boom he designed that is driven by an electromagnetic current. That current, which gradually grows stronger, is distributed throughout the boom, creating a magnetic gradient that pulls in the magnetized oil. The boom, which has a Teflon exterior, moves the oil across an axis. Once the magnetized oil moves along this electromagnetic boom, it will eventually reach a conveyor belt system that is also magnetic. While the excess water drips off the belt, it keeps the magnetized oil, delivering it to a separation container that also has a magnetic bottom. The magnetite naturally goes towards the strongest magnetic force and will stick to the bottom of the container, while the oil and any remaining water separate. This allows for the magnetite to be reused and for the oil to be removed.
You'll be moving the oil, you'll be guiding the oil, you'll be containing the oil, and you're getting out of the water. It's still oil, and we haven't done any chemistry. We haven't put any chemicals in it. So we haven't changed the state of the oil. We've removed the magnetite.
So Arden, how is this technology going to impact the way we clean up spills and the environment?
I think if you can utilize magnetic forces and not use passive systems, you have an advantage. I think if it's efficient, we can clean up spills more quickly. It's environmentally friendly. Since we recover the oil, we can reuse it. Since we recover the water, we can put it back in the ocean in principle. Oil is a messy business when it spills. We could see that from our demonstrations. But if you have a system where you just pretty much put it out there and let it get messy and let it do the work, I think there's a big advantage.
In the United States alone, we import approximately 10.6 million barrels of petroleum product every day. As long as we continue to consume oil at that rate, spills will remain an inevitable part of our future. But our helplessness in their aftermath doesn't have to be. With people like Arden committed to developing new technologies, we'll be better prepared for the challenges that lay ahead.